Okay, so determine the degrees of freedom to find and interpret t-scores. So we want to basically find a t-score for a situation like this. Now, I hope you guys remember that you're only using t-scores and t-stuff when you're doing confidence intervals, and we're doing confidence intervals here, but for mean, when sigma, the population standard deviation, is unknown. And so it's important to be able to recognize that, whether the problem tells you or not. So like in this case, suppose the number of calories eaten by adults in a single day are normally distributed. The population mean and standard deviation are unknown. Now, they don't necessarily have to tell you that directly, but they do here, which is nice. So our sigma, which is our population standard deviation, is unknown. And that is going to indicate that I'm going to end up using t-scores, okay? A random sample of 24 adults, so my sample size is 24, is taken to estimate the mean calorie intake. Determine how many degrees of freedom there are, which we would need anyway if we were going to do the next part. Then use a calculator to find the t-score. That should be used to find a 90% confidence interval estimate for the population mean. So if you guys ever watch my stuff, confidence level is 90% or 0.90. And my confidence level gives me my alpha, my significance level, which is the complement, which in this case is 0.1. Okay. Now, when we're doing critical values for confidence intervals, we need to divide alpha by 2 because it gets split into 2 pieces. So in this case, 0.10 divided by 2. Whoops, let me back up real quick. I don't know why I wrote that twice. So let's write that again. Okay, there we go. So we have, again, alpha 0.1 divided by 2, which gives us 0.05, okay? Now, our critical t-score has this notation, which in this particular example, we already did alpha over 2. Alpha over 2 is 0.05. So we want the t-score that has this area to the right of it, which I'll say is approximately, which if I were to draw this normal distribution curve, and t-score as a student t distribution is also normally distributed, or at least symmetric and bell-shaped. So this area in the right tail, and technically we divided alpha into 2 pieces because confidence intervals have 2 portions. We're only going to find the critical value in the right tail because that's the positive one. And alpha was split into 2 pieces, so this area is 0.05. So I want this value here, which the notation states is a critical t-score with this area in the right tail. Now, when you're doing student t distributions, you do need what we call degrees of freedom, DF, degrees of freedom, which are not difficult because all you have to do is n-1. So once you know your sample size, just subtract 1 and you have your degrees of freedom. So we have everything we need that we can actually go to our calculator. So second vars is where we find our inverse t. So just like z-scores, inverse t for t-scores. The area is 1 minus 0.05 because the area is always area to the left. And in this case, we know the area to the right. So we subtract it from 1. Degrees of freedom are 23. We paste, enter again, and we have a critical t-score. We want to make sure we're rounding how we're asked to round. Does it tell us? Typically, we round to 3 for t-scores if it's not told. So we have a 1.714 for my critical t-score here.